Hello and welcome to this video on Moments of Inertia. Now, Moments of Inertia is a topic that was in the old A-level further maths under Mechanics 4 and now is not, so this is actually more an A-level physics video than an A-level maths video, but it can come in useful in maths as well, hence why the question I'm actually doing is a maths question, despite the fact that it also counts as a physics question as well. Anyway, we'll leave the audience to argue the eccentricities of what's a maths and what's a physics question, and let's just get on with the topic. Now then, inertia is basically the rotational equivalent of mass, to a certain extent. It's what we use when we can't assume an object that is rotating to be a point mass. And usually a moment of inertia is given by I is equal to the sum of the mass times the radius squared. And I could go into a long and complicated derivation of why this is true. I'm not going to bother. You can use Google, I'm sure you can find it out yourself. I'm just here to show you how this works. Now, if any kind of moments of inertia question, you will need to use the sum of mr squared. Now, if we were using rods or discs or cylinders, you have specific formulas for that. This is not one of those cases. This is just a straightforward moments of inertia question. In physics, if you need to use a moment of inertia that isn't basically mr squared, then it will be given to you, so it's not that bad. Anyway, here is the question. A thin wire has length 1.4 meters and is of negligible mass. It is bent to form a rigid rectangular frame ABCD where AB has length 0.3 meters. Particles of mass 2 kilos, 6 kilos and m kilos are attached to points BCD respectively as shown in the diagram. You cannot read the diagram. The moment of inertia about the system, about an axis through A and perpendicular to the plane ABCD is 2.24 kgm squared. Now, that tells us that the total moment of inertia of the shape is 2.24 kgm squared. So now what we need to do is we need to work out the distance of each of the masses from point A. Now, in case of A and B, we know it's 0.3, it's handily given on the diagram. But what we still need to know is the distance AC and the distance AD. Now, this is relatively straightforward, because we know that the wire length is 1.4, we know it's a rectangle, therefore DC must be 0.3. Correct me if I'm wrong. Which therefore means we can do 1.4 minus 0.3 minus 0.3, and that will give us 0.8. 0.8 divided by 2 is going to be equal to 0.4. So we know the distance AD is equal to 0.4, and therefore the distance AC, also I say CB, is also going to be equal to 0.4. So now I'm going to work out the moment of inertia of AD, which is given by mr squared. I'm going to write B in the margin, D in the margin, just so you know which particle I'm on about. So that's going to be m times 0.4 squared, which is going to be equal to 0.16 m. And as you can see, the question requires us to find m, so you know we still need to do more maths. For particle B, we know that it's 0.3 meters away. So that can be 2 times 0.3 squared, which will be equal to 0.18. Yeah, that should still be 0.18 kgm squared. Alright, kgm squared, just so you know, that's just the units of momentum, not momentum, inertia, sorry, moments of inertia. So we still need to know the distance AC. Now, as we can tell from this, the distance AB and the distance BC is AB is 0.3 and BC is 0.4, which means we handily have effectively a 3, 4, 5 triangle, which means we know the distance AC is going to be 0.5 meters. If you want to, we can do square root of 0.3 squared plus 0.4 squared, and we'll still get out 0.5. Anyway, you can prove that in your own time. So now we finally have particle C, which is given by 6 times 0.5 squared, which is going to be equal to 1.5 kgm squared. So now we just got to do the final bit, which is 2.24 minus 0.18 minus 1.5 minus 0.16 m is equal to 0. Is going to be equal to 0 because it should balance effectively. Which means that what we end up with is 0.56 m, sorry, 0.56 being equal to 0.16 m, because that's the well, effectively that's the inertia. That's the inertia that's left after you take off C and B, which means what we have. Oh, sorry, as you can see there. We just need to do the maths, and therefore m is going to be equal to 0.56 over 0.16, and m is going to be equal to 3.5 kg, which is our answer. Again, very simple, similar to the video that I did on angular momentum. Most of these questions is a case of plugging numbers around in a formula, rearranging and seeing what you come out with. Obviously, as you can tell, I could plug 3.5 back into this, and therefore I could see if I get my moment of inertia to be 2.24 kgm squared. Thank you very much for listening.